So as I said, guys, on switched network, we must have designated port, right? And designated ports are always in forwarding state. Look here, pay attention. We have access ports, right? Access switches right here. So all computers are connected to access switches. Then we have distribution layer switches. Think logically, guys, how they assign MAC addresses. Of course, first product, it has a lowest MAC address. Let's say MAC address, very first product, it will have number 1, right? Latest switch, think logically. If we have mixed switches in switched network, old switches and the latest switches, by default, old switches, which are 4 years old switches, of course, those switches will elect root switch. Oldest switch, weakest switch by default will be a root switch. Nonsense, right? Why all traffic must go through that weakest switch if we have here in switched network latest switches, more powerful switches? And here is the situation. Look here, everywhere we have green lights here, but on this switch, at this switch right here, we have orange, that is in blocking state. So nonsense, right? These switches are distribution. See this distribution, and those are access. Why on distribution layer switch we have blocked port? So we can change the configuration. Here, first task, using the below topology, please implement spanning tree protocol with distribution switch 1, which is this one, as the root bridge for VLAN 1, and distribution switch 2 as the backup. So they are asking us to make this switch as a main switch, root switch, and in case something happens, they're asking us to make distribution to switch backup switch. So here we have redundancy path. And in switched network, redundancy is important, because if one direction will go down, one switch will go down, of course, all traffic must go through that backup switch. So, and here is the task, and they're asking us to make this switch as a secondary switch, backup switch. First of all, let's check if all ports on root switch, if we have all ports designated. Let's check how to check. Let's start from here. Command line interface. And here's the command to check spanning tree protocol. Enable. Show spanning tree. Show spanning tree. And let's see. Look here. I'm checking distribution 1 switch. Look what we have here, right here. Role, 1 port is not designated. As I said, all ports must be in designated state, designated ports on root switch. This means that this switch is not root switch. Let's find out where is the root switch. Of course, this switch also distribution not designated because one port is blocked. Look here, it's blocking. Let's check. Show spanning tree. And look, indeed, this port 3, is in blocking state. Look, blocking. So this switch also is not a root switch. One of these switch is a root switch. Let's see. Show spanning tree. Look here what happens. This means that after running spanning tree, look, this switch is a root switch. Nonsense, right? How to change? And also look here, spanning tree, root ID, MAC address, and bridge ID, which is current switch MAC address. This means that that switch is a root switch. Our goal, how to change and how to make distribution one switch as a root switch. Because right now all traffic will go through this switch, access layer switch. Config terminal, and we are typing spanning tree VLAN 1 and question mark, and look here, priority, or we can type root. Let's type priority. And before, look here. In this slide, I told you that priority number is 32,768. Here we have 69. Why? Because VLAN 1, 32,768 plus VLAN number will increase this number by 1, making 32,769. If we have VLAN 10, then we will have 32,778. Priority number plus VLAN number, how it works. Okay, now spanning tree VLAN 1 priority. Priority, and look here, question mark. Now, we must reduce default priority number by 4,094. But usually, if you want to make this switch as a root switch, we can make priority 0. Okay, and hit enter, and look what happens now. Look, now those switches are sending BPDUs to each other. Look here, everywhere we have oranges, right? They are sending BPDUs, and finally they will select this switch as a root switch now, and see how long we are waiting, about 50 seconds we are waiting. Too long, right? 50 seconds. Now, after 50 seconds, now let's check this switch. If you made this switch as a root switch, do show spanning tree. And indeed, look here. Now we have all ports are designated ports, and all ports are in forwarding state. We made this switch as a main switch, a root switch, forced, because we changed, because when we just connected switches together by default, they selected the switch which had lowest MAC address. Now, after making configuration, we changed and assigned a lowest priority number to the switch, making that switch as a root switch. Now, who is secondary switch? Of course, we need to make this switch as a secondary switch, I mean backup switch. In case something happens with the switch, all traffic must go through the switch. But right now, the switch is not secondary switch because those ports are in blocking state. Let's make this switch as a secondary switch. Configure terminal, spanning tree, VLAN 1, and priority. And look, if we assigned to distribution 1 switch priority number 0, to make this switch secondary switch, backup switch, we have to increment that 0 and add 4096 and typing 4096, and it will be now secondary switch. Okay. Okay, let's see. To show spanning tree. See, look here, LRN. This is now I will explain you. It takes time again. So though previously those ports were in blocking state, now first after blocking, when we made that switch as a secondary switch, those ports went to listening state, then learning state, and let's check now if role is changed. Look here. Now all ports are in forwarding state also, but one is root. So why is taking so long time? Can you imagine in switched network to wait 50 seconds? It's a bad thing, right? Our switches must go in forwarding state immediately. And we have advanced protocol, and we call Rapid Spanning Tree Protocol. So STP is default spanning tree protocol, and Rapid Spanning Tree Protocol is advanced spanning tree protocol. We have to change spanning tree protocol to a rapid spanning tree protocol. How? Here is the configuration. From global configuration mode, typing spanning tree mode, and look here, Rapid PVST stands for per VLAN spanning tree, and I will explain you what does it mean, per VLAN spanning tree. Now let's change Rapid. Look here, immediately after we changed, again, ports went down and immediately. Before we were waiting 50 seconds. Now, after a few seconds, all ports are up. See, now those ports are going and up and down because other switches in switch network still run default spanning tree. So protocols are mismatched. The spanning tree protocol is mismatching. So we have to change configuration in other switches also. The change here also spanning tree mode rapid. Okay. Now those ports went down. The change here. See, immediately now those ports are up. Configure terminal. Let's change also here. Spanning tree protocol. Spanning tree mode rapid. Okay. And also change here. Enable. Configure terminal. Spanning tree mode rapid spanning tree. Okay. So now look here. Immediately the port was up. This is the way how we are configuring latest switches as a root switches. So spanning tree protocol topic is enough for today.